I will state the central limit theorem for sample proportions and show its application. The central limit theorem for sample proportions states that if P is the proportion of a population that possesses a certain feature, then P hat, the proportion of a sufficiently large sample that possess the same feature, is approximately normally distributed with parameters mu p hat and sigma p hat that can be related to p, the population proportion, and n, the sample size. In this context, a large sample is such that the number of positive responses and the number of negative responses are both greater than 10. Symbolically, the statement can be written in the following way. Now, I will show an example of an application of the central limit theorem for sample proportions. Consider the following problem. According to a study, 5.4% of the passengers fly first class. A random sample of size 215 was obtained by a researcher. Find the probability that at least 10 people in the sample are first-class passengers. To start solving this problem, we first have to introduce a proper notation. Let P be the proportion of all passengers that fly first class. Then, according to the problem, P equals to 0.054. Now let P hat be the proportion of the sample of 215 randomly selected passengers that fly first class. Next, we find the product n times p, which is 215 times 0.054, which is 11.61, which is greater than 10. And we find the product n times 1 minus p, which is 215 times 0.946, which is 203.39, which is also greater than 10. Since both of these products are greater than 10, the sample is large enough for us to use the central limit theorem, which states that the sample proportion p hat is now normally distributed with mu of p hat being equal to p, which is 0.054, and sigma of p hat being equal to square root of 0.054 times 1 minus 0.054, all that divided by 215, which is equal to 0.0154. Now the probability that at least 10 people in the sample are first-class passengers can be expressed as the probability of the sample p hat being greater than 10 out of 215, which can also be rewritten as the probability of p hat being greater than 0.0465. We can standardize this variable as the distribution is normal and use the z-table, then the answer would be 0.6879, or we can just use technology right away, and then the answer will be slightly different, 0.6869. And now we have a complete solution. I just stated the central limit theorem for sample proportions and showed its application.